2020 seemed to become the year of the environment. We stopped going out, driving cars, taking planes. Instead, we reduced our lives to a minimum, and in the end, CO2 emissions went down by 5.8%. How is that possible? Buildings are the greatest polluters on this planet, with cement production alone being responsible for 8% of global CO2 emissions. And timber is the most promising alternative to that, being regrowing and CO2 negative. However, it is very hard to avoid concrete in multi-story buildings, considering sound and fire regulations. And even worse, timber comes with a lack of thermal mass and therefore passive cooling. And with building operations causing 28% of global CO2 emissions, this can easily kill the initial CO2 advantage and nearly rules out timber construction in hot climates. And this becomes most apparent in floor slabs, which often constitute more than 70% of load-bearing volume. And timber earth slab is the attempt to combine the advantages of concrete and timber slabs into one system, which doesn't feature more than a load-bearing grid filled up with earth, but with the two materials complementing perfectly, and the technology of ETH spin-off Oxar allowing for earth to be cast like concrete. The system promises to combine economic efficiency, sustainability, and high performance. But can such a system even work? There's only one way to find out. We built 3 prototypes with 3 meters span and let them dry. And the result was better than anyone had imagined, because not only did our tests show that the system actually works out, but it also provides a pleasing and natural aesthetic, making the biophilic character tangible to the user and making gypsum encapsulations a thing of the past. To achieve maximum impact, the system is tailor-made for automated planning and fabricating, and the geometry is generated with parametric input and evolutionary optimization algorithms. Featuring maximum automation, the system allows for a whole new level of complexity and individualization. The load-bearing structure is fabricated in a robotic way, allowing for high material efficiency. And thanks to its minimalistic design, the whole system is extremely easy to produce in an automated way. And after drying in the factory for about 2 weeks, the component is ready to make its way to the construction site. Applying design for automation, we envision a future where not only building industry becomes carbon negative, but where no humans have to work under the treacherous conditions of a construction site, allowing us to fabricate any quantity of sustainable, affordable, and high-quality built environments for all people on this planet.